Okay, so last time we did the part one of the population mean. Today we're going to continue on with that. So let's move on to page 535 and see if we can actually construct, let's actually see if we can do a confidence interval for a mean. Okay? Let's go to the example where it says more books on 535. In the previous section, you learned about 73% of the American adults claim to have read a book in the previous 12 months. This was based on a 2016 Pew Research Center study that interviewed a random sample of 1,520 American adults. The same study also reported that the average number of books read was 12 books with a standard deviation of 18. Construct and interpret a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. Okay, so the things that we were given is this is equal to 12, S of x is equal to 18, and there were the population, or the sample size was 1520. Okay, so we're going to go back to our handy dandy old pal state. So we're going to do what? We're going to do a construction. We're going to construct a confidence interval of what percent? 95%. So we're going to do a 95% confidence interval for the mean number of adults, the number of books U.S. adults read in a year, right? Okay. Say so. Our plan is we need to check our conditions. So it was a random sample. That's good. And the n is that, and there are a lot more U.S. adults than that. So we satisfy the not oversampling condition. And our sample size is greater than 30, so everything's good there. So everything was met there. Now let's go ahead and do it. So we have 12, right? X bar plus or minus. Then I have to find this guy, right? And then I'm going to use 18 divided by the square root of n. The square root of n is this guy here. So what we need to find is the critical value for t. So I'm going to go to the back, table 3. And what is my degree of freedom here? My degree of freedom, since this is n, my degree of freedom is this guy, 1 minus that. Okay. So if I look there, I'm going to get what? I don't have that, so I'm going to go the one that's smaller than that's 1,000. And I'm looking at 95%, so I'll be looking at 5%. So I have 0.962 there. Yeah, correct. 0.962. 1.962. 1.962. So this guy here is, I found this guy as 1.962. And this is from reading off the value of that, right? Because it's 95% and it's a double-tailed, right? So I'm looking at this guy here and this guy here. So 2.5 and 2.5% add to become 5%. Okay, so that's where I find that guy here. So I'm going to go ahead and plug and chug this guy into here, and I'm going to put 1.962. Okay, and if I do that, I get a confidence interval of 12 plus or minus 0.91. So I get 12 plus or minus 0.91. So the confidence interval itself is going to be 11.09 to 12.91. Okay? So on the very end, we're going to conclude saying that we are 95% confident that the interval 11.09 to 12.91 captures the true mean of books that U.S. adults read in 1 year. Okay? So that's how you conclude there, right? And B, in 2011, Pew reported that American adults read an average of 14 books in the 12 months. Does your interval from the part A provide convincing evidence that it is different from 14 books? Well, it does, right? Because 14 is not in our confidence interval. Since we are 95% confident that this would capture it, and they're talking about a number that is outside of there, where the answer would be yes. We do have convincing evidence, right? Okay, that's good. So obviously you can also do this in your calculator. Okay, in your calculator you would use stats and you would go to test. So you go stats test, and the test that you're going to come up with is going to be a t-interval test. You're going to look for a t-interval test, and the t-interval test on page 537, it goes ahead and asks for this, this, and this. So it's going to give you this, this, and well, it's going to give you this, this, and this, and also the confidence interval, right? So you need the confidence interval also. So you give those 4 numbers, and then it'll plug and chug for you. Okay? So know that obviously there's a way to do it with your calculator also. Okay? Now one of the other things that we're going to talk about here is how to choose a sample size. Okay? When we chose a sample size back when we were doing proportions, okay, we did the margin of error was what? The margin of error was the critical value P1 minus P over N, correct? Okay, and if we did not know what P was, we went ahead and used 1/2, and then we just used it from here so that we knew this guy, and we're just going to put 1/2 in here, so this was easy to calculate, no problem, right? Well, in this one, it's a little different. In this one, in the mean, now the margin of error is going to be this guy and this guy. Okay? So, we do not know this because we have not done the survey yet. This comes only once we do the survey, right? So I don't know this. Okay? The other problem is that this guy is actually tied to this. In other words, to find the critical value, you need to know the degree of freedom. And the degree of freedom comes from this. Okay? So we can't do that. What we're going to do, what we do, is that we're going to go ahead and use this. Well, you will say, well, I don't know this guy either. And you would be correct. So the way we say is that we're going to find a study that looks similar to what we are doing, and we're going to use the result that they got for their standard deviation, and we're just going to put that in there. Okay. So if you go to page 539, it tells you that to determine the sample size n, where that will yield a C% confidence interval, you get a reasonable value for your population standard deviation sigma from an earlier pilot study. Okay, so once you use that, okay, once I have that, once I know this, now I do not need to do the t-distribution. Now I can actually use a normal distribution. Okay, and that unties this guy from this guy, right? So now the only thing that we do not know is this, and we can solve that, right? Using what the desired margin of error is, okay? So 2 things here. So we start from, so we're going to start from this guy, right? We started from this guy, but we changed this by saying, I don't know this because we haven't done the study yet, so I'm just going to borrow one from another study. Okay, and we're going to do this, and now instead of using the t-distribution, I'm going to use a normal distribution, and this is going to be how you're going to calculate the margin of error. And that is on page 539. And so let's go and do the example there underneath on page 539. How many monkeys researchers would like to estimate the mean cholesterol level of mu of a particular variety of monkey. Okay, they would like their estimate to be within 1 milligram per deciliter of a true value of the sigma, the mu. In other words, 1 milligram is your margin of error. So 1 milligram is going to be your margin of error. So you want this to be the margin of error, right? And that's, so in other words, this guy here has to be less than that, less than 1, right? Okay, and then we were told it is a 95%, it's 95 confidence interval. So if you remember correctly, our normal critical value for 95% was 1.96. And it gives us a sigma that they found earlier. And the sigma was 5. So it's going to be 5, and then this is the square root of n. This is what you're trying to find out for, right? So I'd multiply square root of n on both sides. So this guy's going to go away. Square root of n. Now I square both sides, right? So I'm going to square this. And that's what I'm going to find, right? And if I do that, what do I get? I get 9. This is 96.04. So n needs to be at least 97. I need at least 97 monkeys to find out how this works, how to find it, to get to the 95% confidence interval. Okay? And that's it for today.